Today's topic is Boolean algebra. Let us take an example of OR gate. This is a OR gate. It is having, let us say, input A and B, and output is Y. You know that if you want to draw the truth table, then for the two inputs you have four possible combinations like that. These are the four possible combination, and this for 0 0, Y is 0. For 0 1, Y is 1. For 1 0, this is 1, this is also 1. Okay, now if you want to just find out the relationship between this Y and A and B, so you can write like this: Y is equal to A plus B for this OR gate, and this expression is called as Boolean expression. Okay, this expression is basically Boolean expression. So we'll discuss here. We'll see in the coming classes how you can just find out a Boolean expression from the given truth table. So this is where you just have a this type of input output Boolean table. This is called as truth table. Okay, this equation is called as Boolean expression or Boolean equation. Okay, this is Boolean expression or Boolean expression. So now let us say that now let us define what will be the Boolean algebra. So as you can see here, a Boolean algebra is a closed algebraic system containing a set K of two or more elements and the two operators. This operator is dot, where we can say that is multiply, and plus, which refers to, this dot refers to AND operator. Okay, that is multiply, and this plus, this is OR operator. Okay, if I am writing here, if I am having two bits, so if I am writing A plus B, then A or B, you can say that. If I am writing A dot B, dot is there, then you can say that A and B. So these are the two operators. A third operator is also there, that is not. We will discuss it in the this later half of this lecture. Now, so basic identities of Boolean algebra. If you are having two bits in this Boolean, we will discuss Boolean stands for binary system, in which we have two bits, 1 and 0. So here you can see here x plus 0. What is x plus 0? Now x can be 0 or 1. Okay, so if you add any binary number x with 0, that will give the same number x. Okay, you can see that, like, just put the value of x here, 1 plus 0, that is 1. Okay, so x will be 1, so you are getting x. So what is, if x is 0, 0 plus 0 is 0, so you get the x again. So x plus 0 will always be x. Anything that is x and 0, this multiply is 0 basically. So just remember that anything multiply by 0 is 0. X plus 1 is, if you add anything in this 1, that would be 1. Remember this. How? Just take here, let us say x is equal to 0. So 0 plus 1 is 1. If x is 1, let us say x is 1. So 1 plus 1 is 1. In the both the cases, you are getting 1. So output will be 1 here. Anything multipliable 1 will be written in the same term. So that will be small x here. Okay, you cannot write capital X here. If you are dealing in small x's, so that would be small x. Okay, correction here. So you need to remember these identities. Now, if you are adding two variables, x plus x will be equal to x. So you can also write like a plus a will be equal to a, or you can say that b plus b is equal to b. You cannot write 2b, you cannot write like this, a plus a plus a. That, okay, oh sorry for that. You cannot write here, that would not be equal to 3a. Okay, so some correction is there. So I am writing here a plus a is not equal to 3a. Okay, that would be equal to a. How many times you will add it, that will be equal to the same number. Okay, x and x will be equal to x. So you can also see here, if you have another variable a dot a, that will be equal to x plus x bar. Bar is a complement here. Okay, you can also write like this, x bar, or that will be equal to x bar. This is also bar. You can write this bar two ways. This is note basically, x note. Okay, as I told you, the plus sign is or operator. This dot sign is and operator, and this complement or this bar, this is not operator. Okay, so x plus x bar will be equal to 1. Okay, x plus x bar will be equal to 1. You need to know how to prove it. Let us say x is 0. What would be x bar? X bar will be 1. Plus is 1. If x is 1, what would be x bar? That will be 0. That will be equal to 1. So that x plus x bar will always be equal to 1. X dot x bar, because here will be equal to 0. Now if x is 0, what would be x bar? That is 1. Okay, you will get 0 here. If x is 1, what would be this x bar? That would be 0. So you will get 0 again. Okay. Now another, this is the basically commutativity, that's a commutative property of Boolean algebra. Okay, so if you are having two Boolean terms like this, x and y, if you added x plus y, that would be equal to y plus x. Okay, so similarly, if you are having a plus b, you can write it like this, a b plus a. That would give you the same result. Now this is also in AND operation. X into y is equal to y into x. Similarly, a into b will be equal to b into a. So you can assume dot here. Okay, by default, if dot is not given, okay, two numbers are written adjacent to each other, one after another, so you can say that dot is there in between. Okay, so and is there. Okay, this is the commutative property of Boolean. You can also prove it. Just put the value of x and y. Okay, the value of x can be 0. Value of x can be either 0 or 1. Similarly, value of y can be 0 or 1. So you can just take the cases and just prove it. Then the associative property or associativity of Boolean algebra. So here, if you are dealing with the associate property, now this here you can see here, if you are having this x plus in brackets you have y plus z, so you can write it like this, x plus y plus z. Okay, if you have addition of this three numbers like this, x plus y plus z. Okay, if you want to add this x plus y first, add it, then add z. Or if you want to add y plus z first, then you want to add x, then do it. Okay, so here what we are doing, we are adding this y plus z first, then we are adding x. Here what we did, that will be equal to x plus y, we have added x plus y, then z. So this is associative property or associativity of Boolean algebra. This also this in multiplication. In the multiplication, you can see that here we have multiplied y z first. So dot is here. Okay, assume dot is here. Okay, dot is here. Now if you have multiplied y and z first, then with x. Okay, here what we did, that would be equal to, if you multiply x with y, then the result will be multiplied with z. That will be equal. Okay, this is associative property of Boolean algebra. Now the distributive property of Boolean algebra. Now here you see that you have both the operation here. We have a AND operator here. We have a OR operator here. So if you open the bracket, you can multiply this x with y. Okay, x is multiplied with y, and x is also multiplied with z plus x into z. This is the result. This is distributive property. Similarly here you can write like this. This is very important. Just keep it. This is very important. X plus y into z. So that will be equal to x plus y. That is a multiply here, and x plus z. This is very important. Just remember this. Okay, we will use it again and again. Let's remember this. Now we also, this is again very important, De Morgan's theorem. Very important, De Morgan's theorem. It states that if you have a complement of two numbers like this, okay, you can write like this also, x plus y whole bar, x plus y whole bar. Okay, this is the, so you will get the result like this, x bar. Okay, this bar will be on x, and this sign will change. If we have a plus here, that will be converted to multiplication. Okay, then you'll get y bar. Okay, so this is the number x plus y. You can also write like this, by whole, the complete bar is there. So this is x bar dot y bar. A dot is here. Okay, now again here, let us, this is, you can also write like this, xy whole bar. A dot is here. By default, you can assume that dot is here. So that will be equal to x bar, and this multiplication will be converted to plus y bar. You can write this. Okay, so this is the De Morgan's theorem basically. Now this is also true. Now if you have a double bar of any number, so that will be equal to the same number. This bar will cancel out. Okay, if you have two-time complement, if you take the two-time complement of any number, that will be equal to the same number. Okay, if you take this 0 bar, double bar, that will equal to 1 bar, that will equal to 0. So if you take two-time bar of any this binary number, that will be the same number. So this is how you can write like this. Now let us solve some problems. So here number is given a plus b. So you can take a common from this, because a from this, a from this. So take a common. So in the brackets, what you get from this? 1 from that, and b from this, 1 plus b. What is 1 plus b? Anything 1 plus b will be 1. So a dot 1. A dot 1 is a. So answer is a. Another is a dot a plus b. So open the bracket, distribute it. A dot a, that a is multiplied with a. Again a is multiplied by b. A dot b, dot is here. Okay, clear? So what is a dot a? We have already learned as x dot a. X was x, so that will be a plus b. Okay, now take a common again. This is the same part, na? A plus ab is equal to a, same part. Okay, so next part is a plus a bar b. A plus a bar b. So you can write here, just take this a here. So you can write here this a plus a bar into a plus b, like this. What is a plus a bar? A plus a bar is 1. So you'll get a plus b. Answer will be a plus b. Next part is a, this is dot here, a bar plus b. Just open the bracket, distribute it. A dot a bar plus a is multiplied by b, ab. What is a dot a bar? That is 0. 0 plus ab is ab. So this is how we can solve the different Boolean algebra. Okay. Now this is the De Morgan's theorem. We have already studied it. So here you can see here this A plus B, you can also write like this complement, that will be equal to A complement, that will be converted to multiplication B complement. Okay, simple. Now here what you have, A dot B whole complement, that will be equal to A complement, so that will be converted to plus B complement. Okay, simple. So complement you can write, as I already told you, like this, that will be equal to this. Okay, you can write, you can choose any method. Okay, this is more convenient, A bar. Okay, okay, this is a generalized method, leave that. Now let us solve a problem by using this. It is given to you, y is a function of a, b, c, d. It is given to you a, b, c, d complement plus cd plus bc plus a whole complement. This is given to you. You have to solve it. Okay. So assume, so whole complement is there. So assume this is the first term, this is the second term, third term, and this is the fourth one. Okay. So here you can write like this, A, B, C, D. So complement is there. So another complement will be there. Okay. So this is the first term. So sign will change here. That will be converted to multiplication. So C, D complement will be there. So this sign will also change here again. BC complement is there. This sign will also change here. Dot A complement. Okay. Now again this double complement will be cancelled out. So you will get A, B, C, D. Okay. So start bracket here. So you will get here C bar plus D bar. Sign will change here by using De Morgan's theorem. Again put a bracket here, dot. So you will get what? B, C, this B bar plus C bar. Okay. So A bar is here. Okay. Now that will be equal to A, B, C, D. This is B actually. Okay. This is B. So open this bracket. This multiply this A with all the terms and open the bracket. So we'll get C bar plus D bar. Okay. Open the bracket and just take this here. So we'll get A bar, B bar plus A bar, C bar. Now you can also write like this, A, B, C, D. Open this bracket also too. Just multiply this term. Just change the color first. So multiply this term with this one. So you will get what? A bar, B bar, C bar. This term with this plus A bar, B bar, D bar. This term with this. So you will get A bar, C bar, again C bar. This term with this D bar plus A bar, C bar. So I am writing this here, A bar, C bar and D bar, bracket close. Okay, clear? So you will get like this, A, B, C, D multiply. So you will get here A bar, B bar, C bar. Okay, plus again here A bar, B bar, D bar. 2 times C bar is there. So you'll get A bar, C bar. Okay, and here you'll get A bar, C bar, D bar. Okay, simple. Okay, now if you multiply this whole component with this, so what is this A bar? You're getting the term A bar, B bar, C bar. So what would be A into A bar? That will be equal to 0. If you multiply this term with this term, you will get 0. So result of this term will be 0. If you multiply this term with this one, again plus 0. You multiply this term with this one, again 0. This term with this term, again 0. So you're getting 0 here. Result would be 0. So this is how we can solve Boolean theorem. So I'm giving you a question to solve. So solve this. Y A B C, that is equal to AB CD plus BC plus AC plus A whole bar. Just solve this. Okay, minimize this by using Boolean theorems. Okay, that's all for today. Thank you.